Hello good day viewers. In this tutorial we want to show that this mathematical statement is true in the set of natural numbers. We are asked to prove by induction that the summation of natural numbers from 1 to n is exactly equal to n multiplied by 1 plus n divided by 2 for every number you picked at random from the set of natural numbers. Before we start, you should observe that the right hand side is familiar because we use it in finding the sum of n terms of natural numbers. For instance, if you wish to add 1, 2, 3 to 10, you can just apply this formula instead of adding the terms together. Let me show you an example. Suppose we want to say 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. You know, this will give us 55. But what if we have thousands of terms? No, we cannot just go ahead to add them like this. Instead, we can use this formula in the set of natural numbers, where n is 1, 2, 3 to 10, which is 10, right? N equal to 10. We have 10 multiplied by 1 plus 10, divide by 2, where 2 can go into 10 5 times. And in the bracket, we have 1 plus 10, 11 times 5 equal to 55. You see, as simple as that. And the left hand side means summation. You should add these terms starting from 1 and you stop at n. So if you have n equal to 10, it will be equivalent to what we have just done here. Okay, let's get started with the solution. As you know, we have three basic steps. The step 1, we're going to test for n equal to 1, where 1 is the first term in the set of natural numbers. So we say step 1. All we have to do is to substitute the value of n equal to 1. So it means that from the left hand side, we are going to begin with 1 and stop at 1, meaning we have only a single term, which is 1. So the left hand side will be just 1. Is this the same thing as the right hand side? The right hand side will be 1 multiplied by 1 plus n is also 1 divided by 2. In the bracket, we have 1 plus 1, which is 2, and 2 multiplied by the 1 outside is still 2. 2 divided by 2 is 1. So the right and the left hand side are all equal to 1. So in step 2, we want to assume a certain number in the set of natural numbers will also satisfy this statement if and only if 1 satisfied. So let us check another number in the set of natural numbers to see whether this is true. We're not going to use a number, rather a variable, for instance, k. So in step 2, we are going to set n equal to k, for which k belongs to the set of natural numbers. So let me substitute. This will be summation of natural numbers from 1 to k, which is the same thing as k multiplied by 1 plus k divided by 2. So we are assuming that this is true, right? We just assume. We assume that this is true. If it is true, we are going to prove that any number after k will also satisfy this statement. For instance, if 7 satisfied the problem, we want to show that 8 will also satisfy the problem, meaning 7 plus 1, which is the next term. So if k satisfied, we want to show that also k plus 1 will satisfy the problem. You know, the left hand side of this expression means 1 plus 2 plus 3 plus ... plus k. You know, this is exactly what it means. And the right hand side is k multiplied by 1 plus k divided by 2. So if this is true, we want to prove that k plus 1 is also true. When n is equal to k plus 1. This is what we have initially. So we are going to substitute n equal to k plus 1 since we have seen that k is true. So we have summation of n from 1 to k plus 1 of these natural numbers equal to wherever we have n, we replace it with k plus 1. This is k plus 1 multiplied by, you know, this is going to be k plus 1 plus 1 that will give us k plus 2, right? K plus 2 divide by 2. But remember, the left hand side, it means we should be adding these numbers from 1 down to k plus 1, right? So let me break it down. This is the same thing as 1 plus 2 plus 3 plus dot 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 plus k. You know, k is the number before k plus 1 plus k plus 1, right? This is the same thing as k plus 1 multiplied by k plus 2 divided by 2. You should observe that from 1, 2 to k is familiar, right? Because that is what we have to the right hand side from here. Can you see that? From 1 to k is exactly equal to this. Therefore, we can substitute 1 plus 2 plus 3 after k with k multiplied by 1 plus k divided by 2. So what we have here is just k multiplied by 1 plus k divided by 2. But we still have another k plus 1, right? We want to show that it is the same thing as the right hand side, which is k plus 1 multiplied by k plus 2 all divided by 2. So let me just go ahead and simplify the left hand side because we have already seen what the right hand side is. So we can rationalize this as divide by 1. To make the denominators the same, we can multiply the top and the bottom by 2, right? So we have k multiplied by 1 plus k divided by 2, then plus 2 of k plus 1 divided by 2. Remember, this is the left hand side. Since we have common denominators, we can add denominators. This is k multiplied by 1 plus k, then plus 2 multiplied by k plus 1. The whole of this divided by 2. We take a common denominator. This can be factorized because you can see k plus 1 in common between the two terms. So we factorize it as 1 plus k. If we factor 1 plus k outside, then inside from the first time, since this is gone, we have only k left. From the second time, 1 plus k is gone, we have 2 left, right? The whole of this divided by 2. Remember, this is the left hand side. But observe that it is exactly the same thing as the right hand side. Let me just copy that. It is exactly equal to the right hand side. This is our right hand side. And we want to always show that whatever value you plug into this statement, the left and the right hand side will remain the same. And since the left and the right hand side are equivalent, then we conclude that this mathematical statement is true. And hence, this formula here is true for all n in the set of natural numbers. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.